Hello, these are the notes for Unit 1, Section 1.4. So we'll put that right here. As usual, please put the date that you're taking these right here. When you are done taking the notes, show them to me and I will give you the worksheet for Section 1.4. It'll be worksheet number 5 that you'll be asking me for. So our objective today is to start a long and many section tasks of factoring. But we're going to start off by just factoring what we call a common monomial. So before I even finish that, I think we need to, sorry about that, I think we need to go and define what a monomial is. So let's do that first. Monomial. What a monomial is it's one term. You won't see any addition or subtraction linking multiple terms and then making it a polynomial. So some examples of monomials, and we've had these before, but here I'll do a different color. Just a plain number 6 is a monomial. Or 6x squared is considered a monomial. Or 7xyw is considered a monomial. If you don't see any addition or subtraction linking terms, we have what's called a monomial. And your task today is going to be to factor a common monomial out of a polynomial. Poly just means many, so out of a many term you're going to factor. Let's circle that word factor. Remember, factor means to break into multiplication. You might even want to think of it as dividing. So let's go put a little bar right here, and we'll discuss how we factor out a common monomial. The first thing you need to do is, let's put one down here. Let's put a nice easy one. How about 5x squared plus 10x. When you look at both of these terms, the 5x squared and the 10x, they have something in common. And what they both have in common numerically, if you look at the 5 and the 10, is they both have a 5 in it. It's kind of like finding the greatest common factor. What's the biggest number that goes into both of them? If you can't find one, then you can't pull anything out. So I can pull a 5 out of both of those terms. I can also divide an x out of both of those. I can't take 2 x's out because this one can only afford to give me one of them. So once I determine what I can divide out, that's called my common monomial, what I do is I basically undistribute it, which means instead of multiplying it in like we did in the last section, we're going to divide it out. You might even want to divide it out physically by putting it underneath each term. 5x squared divided by 5x, or when I divide out a 5 and an x, gives me just an x. 10x divided by 5x, the x's would cancel and it gives me just 2. Now, a good way to check that you factored correctly is to distribute this back in. I get 5x times x, which is 5x squared, check, plus 5x times 2, which is 10x, check. So they're very easy to check just by distributing back in. So we're just going to do a couple. So let's go like this. All right, we are going to factor. I'm going to put a couple of them down here. I'll list them first and then we'll go do it. 20p to the 5th minus 4p to the 3rd. We're going to factor a negative x cubed minus an x squared. That one's going to be a little bit trickier. And we're going to factor a negative 6 minus 2x squared. And I'll give you a minute to write all those down. So the first thing we need to do is decide what we can pull out of each term. So we look at the numbers first. Although these are both even and a 2 goes in, we want the biggest thing that goes into 20 and into 4. And so we'd call that, basically, it's the greatest common factor. And for us, that would mean we can divide a 4 out of each of them. So I can divide a 4 out. Next, both of them have some p's to give me, but I have to make sure that, for example, although the first term has 5 of them, the other one only has 3. If you kind of considered it like money and somebody had $5, and another person had $3, and I said, you have to give me the same amount. The most they can give me is 3. So basically what you do is pull out the lowest power that you see. Did you hear what I just said? You pull out the lowest power that you see. So the biggest number that goes into both terms and the lowest power of the variables, that's going to make what we call our GCF, or our common monomial. I'm going to divide it out of both terms. 20 divided by 4 would give me 5. Now if I didn't give it any more p's, you'll notice if I dump that back in, I get 20p to the third power. I need 20p to the fifth power. So I need to give it 2 more p's. And there's my 20 p to the fifth. Remember, when we multiply, we add those exponents. So next, I need a minus sign to create that link. And I already have the 4. So when I divide a 4 out of 4, it just gives me 1. You can put a 1 here if you want. It's not necessary, but if you would like to put it there, that's certainly correct. Also, I already have all the p's I need. So really, when I take 4p cubed, and again, remember what you're doing is you're dividing out that common monomial. And when you do 4p cubed divided by itself, you get just 1. So sorry about all these bells. All right, so on the next one, and again, you can check it by hopping it in. So on the next one, what do they both have in common? First of all, I'd insert a little -1 in here so you understand that there's really a coefficient or a number out front of -1, and they both have one of those. So I'm going to divide out a -1, and then how many x's can they each afford to give me? Only 2. Otherwise, the second term doesn't have enough in there. So then I put my parentheses down, and I'm basically dividing out a -1 x squared. Or you have to figure, what do you need to put back in here to get it back? Now notice, you can always check these. Just hop it in and you get negative x squared times x is negative x cubed, which is exactly what I need to get. Now, this is where it's kind of tricky. I need to make sure that my link is a minus. However, I'm factoring out a negative. So if I put another negative in there, a negative times a negative gives me a positive. So I have to make sure that I have opposite signs. Also, I already have everything I need here, which means I just need to put a 1. That one's quite tricky. Furthermore, you really don't need to have that 1 in there because 1s in multiplication don't really mean anything. So I'm going to repeat what I did with that one over on this side here. I'm pulling a -1 out, which is really just a negative sign. I'm pulling out 2 x's because that's the smallest number of them that they can each have. What do I need to put back in? Well, this one needed 3 x's, so I throw another one in. I need to have a link of a minus, so I need to have opposite signs when I multiply. And then I have everything I need at the end. I need this x squared, and I have it, so I put a 1 there. And again, it can be checked. Negative x cubed minus x squared. So that one's a little bit trickier with all those negative signs. Same with this bottom one. What can I pull out of each of these terms? You might say a 2, which is true, but when both are negative like that, you really should think of pulling out a -2. And remember, and I can't take out any x's because this first term over here doesn't have any x's to give me. So I'm dividing out a -2. If you physically want to write it like that, that's sometimes helpful. So a -6 when I divide out a -2 is a 3. And you'll notice when I hop this back in, I've got my -6. And then a negative divided by a negative gives me a positive here. So I'm going to have a plus x squared, which can be checked. So what I'd like you to do down here is, before you ask me for your worksheet, let's write our little summary of what we're doing. To factor out a common monomial, you need to find what we call the greatest common factor, or the biggest thing, the biggest term that you can divide out. You pull that out front of the parentheses, and then you need to divide it out to figure out what goes back in. Before you ask me for the worksheet, I want you to do this one. A negative 5x squared minus, and let's just say a 25x. I want you to do that one and show it to me. And if it's right, I'll give you the worksheet. If it's wrong, we'll fix it, and I'll give you the worksheet. So you have a great one.